Today's lesson is called Solving Linear Equations, Day 1. We're going to start by reviewing the steps to solving a multi-step equation. The first thing we want to look for when solving an equation is to do all of the simplifying first before we start to solve. And when you're doing that, distributive property should be number 1 on your list. After you multiply using the distributive property, you should be looking to combine like terms. Now we have to be careful with combining like terms because this needs to be done on each side separately. So you need to look at the left-hand side and combine all like terms, and then look at the right-hand side and combine all like terms. Next, you should look for variables on both sides to start solving. Okay, so if there are variables on both sides, you should undo a variable, and that would be with either addition or subtraction. After getting rid of variables on both sides, we're now down to what we would consider to be the same steps for a two-step equation. So at this point, you should be undoing addition or subtraction. Making sure you're using inverse operations. So if there's addition, make sure you subtract. If there's subtraction, make sure you add. Then in number 5, after we undo addition or subtraction, we want to undo multiplication or division. Again, making sure you're using the inverse operation. And then lastly, we always want to make sure we check our solution. So now let's work through some examples to demonstrate these steps. So in example 1, the first thing I want to point out is that we have a special situation here where it looks like there may not be anything in front of the parentheses, but in actuality there is. So the first step you want to write in an equation like this is to actually rewrite it with a -1 in front, so that you realize that there really is distributive property and you should be distributing a -1 through the parentheses. So that would be 8a, and then -1 times 4a would be -4a, -1 times 32 would be -32. So that was step 1, look for distributive property. If it's there, make sure you simplify it. Then I'm going to look for like terms on each side separately. When I look at the left-hand side, I have like terms of 8a and -4a. So that combines to 4a minus 32. On the right-hand side, I do not have any like terms to combine. Next, I look for variables on both sides. I do not have variables on both sides, so I go to the next step, to undo addition or subtraction. So at this point, we want to get rid of the -32 by adding 32 to each side. So we have 4a equals 48. Then I want to undo multiplication or division. So here we have multiplication. 4 next to the a like that means to multiply. So we must do the opposite thing, which is to divide. We should divide both sides by 4. Always make sure you're dividing by the coefficient of that variable. So now I know that a is 12. Now for our lesson purposes, we are not going to be checking since it is time consuming. Make sure that you practice checks when you complete your homework. Make sure you always complete a check on any type of assessment. Let's move on to example 2. So first thing I look for is distributive property. We do not have any. So next I look to combine like terms. On the left-hand side, I have 5x and -2x that can be combined. On the right-hand side, I have 8 and 6 that can be combined. Remember, you can only combine on the left-hand side separately than the right-hand side. So on the left-hand side, 5x and -2x would make 3x plus 15. On the right-hand side, the 8 and the 6 together makes 14, so 2x plus 14. After like terms, I check for variables on both sides, which we do have. It does not matter in this case which variable you get rid of. If there's variables on both sides and the equation is what I call even in size, meaning there's 2 terms on the left and 2 terms on the right, you can get rid of either one. If it's lopsided, where there's 1 term on one side and 2 on the other, it's better to get rid of the variable that's on the side with more stuff. Now, whichever one you choose to get rid of, it doesn't matter. I tend to pick the one that's smaller to avoid negatives. So I'm going to subtract 2x from both sides. On this side, I get x plus 15. Over here, the 2x cancels out, and I have 14. So then I go on to addition or subtraction. I'm going to get rid of that addition by subtracting, doing the inverse operation of adding 15. So I get x equals -1. Moving on to number 3, let's do an example that involves some decimals. So the process still stays the same. First thing I'm going to look for, a distributive property. This 0.08 has to be distributed through our parentheses. So we end up with 0.02m. And then when I do this multiplication, 0.08 or 800ths times 8 would give me plus 0.64, 64 hundredths. And then I would have minus 0.08m equal to 1.78. After distribute, I look for like terms. I don't have any on the right-hand side because that's already as simplified as it's going to get. But on the left-hand side, I can combine my m's. So I would get negative 0.06m when I add those or combine those together. And then I still have my plus 0.64 here and 1.78. Next, I want to look for variables on both sides, which I do not have here. So we'll move on to getting rid of addition or subtraction. I want to get that variable by itself. That's always my main goal. So I got to get rid of that 0.64 by doing the inverse operation, which is subtracting. That leaves me with 0.06m equaling 1.14. Now this is multiplication because the 0.06 negative is written directly next to the m. So I have to do the opposite, which is to divide to get rid of it. And remember, you're dividing only by the number in front, and it should be the coefficient of your variable. Whatever you do to one side, you always have to do to the other. And when I actually do that math, I get negative 19. In example 4, we have some fraction work, still the same steps. So our goal, get x or whatever variable it is by itself. Always look for a distributive property first. We have distributive property on each side, so we'll make sure we take care of that. A third of 21 or a third times 21 would be 7. 1/3 times negative 3x would be negative x. On the other side, we're distributing 1/2, so 1/2 times 8 would be 4, and 1/2 times negative 4x would be negative 2x. Then we'll look for like terms. On the left-hand side, I don't have any, and then when I look at the right-hand side, I don't have any either. So variables on both sides. I do have variables on both sides, so I'm going to choose to get rid of the negative 2x by doing the opposite, which would be adding 2x. Again, you could have gotten rid of negative x, you just would be adding x to both sides. We would still get the same answer. So this becomes 7 plus x equals 4. So then I would be able to subtract 7 from both sides, get rid of my addition or subtraction. If that number is in front and I don't see a sign with it, that is positive, which means we need to subtract. So I would end up with x equals -3. Okay, moving on to the next page, we have other types of solutions. So what I would like you to do is pause the video and try to solve each one of these equations. Then I want you to reflect and say what strange thing happened in each of these cases. Once you've tried these problems on your own, please resume the video to go over the answers. Okay, in our first equation here, I see distributive property. So that should have been negative 8x and then minus 4. On the other side, I don't have any, so just negative 8x minus 2. Then I look for like terms. I don't have any on the left, and I don't have any on the right to combine. So I move on to variables on both sides. I'm going to get rid of negative 8x by adding 8x. Whatever I do to one side, I must do to the other. And what happens is I get negative 4 equals negative 2. So I hope you noticed a couple of things. First of all, the variables disappeared. So variables were eliminated. And the two numbers that I actually are left with are not equal. So you need to make sure you slash your equal sign. So what that means for this type of equation is that there is no possible number that could work as a solution to the equation. So this is an example of an equation with what we say is no solution. Okay, now looking at the other one, we have distributive property. So I have -5 minus 9x equals 3 minus 9x and then minus 8. Then I'm going to look to combine like terms. On the left-hand side, I do not have any, but on the right-hand side, I can combine 3 and -8. So I get -5 minus 9x equals -5 when I combine the 3 and the -8 minus 9x. Then I look to get rid of variables on both sides. So I'm going to add 9x, add 9x. And what happens is, again, the variables are eliminated. But look at the numbers that you were left with. Those two numbers are actually equal to each other. So it changes what we write as our solution. So here, because the variable was eliminated and the numbers that are remaining are actually equal to each other, that means every number could work as a solution. So this is an example of what we say is infinitely many solutions. Now at this time, there are two practice questions that I would like you to try on your own. So you're going to please pause the video, try these two problems, and then when you're ready to check your answers, you can resume the video to go over them. Okay, at this point, you've tried your two practice problems. Let's go over the answers together. In number 1, I had no distributive property. I also had no like terms. So I had to go right into getting rid of variables because I had variables on both sides. So I decided to get rid of 3/4 x by doing the opposite or inverse operation, which is subtracting. So I subtracted 3/4 x from each side. That left me with 2 equals 2/4 x minus 6. So then I want to look to undo addition or subtraction. Remember my goal being to get x or whatever variable by itself. So at this time, I added 6 to both sides and got 8 equals, and I reduced 2/4 to 1/2 x. Then anytime you want to get rid of a fraction, you should be multiplying by what we call the reciprocal. So remember that here, you want to multiply by the reciprocal. Okay, when you do that, you should get an answer of x equals 16. For number 2, starting with distributive property, had to use distributive property in 3 separate places, so I did that first. Then looking for like terms on the left-hand side, I did not have any. On the right-hand side, 3x and -2x are like terms, -6 and -4 are like terms. So when I combine those, I get x minus 10, and on the other side, I still have my 4x plus 20. Now we have variables on both sides, so I need to get rid of one of the variables by, again, doing an inverse operation. I decided to get rid of x by subtracting x from both sides. Then undoing addition by subtracting 20. And lastly, if it's 3x, that's multiplication. So I have to do the inverse operation of division. You should be dividing by the coefficient, which is the 3, in order to get an answer of x equals -10. And that concludes our lesson on solving linear equations, day 1.